Hello and welcome back. Today, let's talk about the relationship between quantum computers and artificial intelligence. Quantum computing often sounds like a concept borrowed from some futuristic movie, yet it is a rapidly advancing reality that promises to transform our data-driven world in many ways. But let's take an accessible look at what quantum computers are, how they work, the applications they can offer, and that synergistic relationship with artificial intelligence that I mentioned just a moment ago. So just what are quantum computers? All right. In our daily interactions with technology, from the ubiquitous smartphones that are in our pockets to the personal computers and PCs, laptops that are on our desks, these are underpinned by what's called classical computing, which depends on bits. These bits are the simplest form of data representation, existing in a state of either 0 or 1. Much like that of a light switch, right? It can be up, on, down, off, right? Another example to consider is the digital display of the number 8 on a digital clock, where each segment of the display can be lit up with a 1 or not with a 0, representing 1 bit. There are 8 such segments or bits, and together they form a byte, which would be that whole 8. This byte can represent not just that number 8, but any number or character in the binary code through different combinations of the on and off states, right? Now, quantum computers depart from this binary tradition by operating on quantum bits or qubits. These qubits are like the alchemists of data processing, almost like magic, capable of existing in a state of 0, 1, or both simultaneously, thanks to the quantum phenomenon known as superposition. This attribute empowers quantum computers to process extensive data sets at speeds that far outpace any traditional computer by many orders of magnitude, right? Now that we understand a little bit about what they are, how do they work? Well, first we need to dive a little bit into the crazy world of quantum mechanics. At the subatomic level, inside the world of an atom, particles behave in ways that defy the rules of classical or intuitive physics. And there are 2 key principles that the quantum computers exploit. First, we have one called superposition, which allows qubits to operate in a multi-state capacity. Imagine a globe with poles representing the classical binary states of 0 and 1, the North Pole and the South Pole. Every point on that globe's surface symbolizes a qubit's possible state, a superposition of 0 and 1. This means a quantum computer built with multiple qubits doesn't solve problems step by step. It explores multiple solutions simultaneously. So, let's say you're solving a maze, right? A classical computer would try one path, hit a dead end, go back, try another, and keep going until it finds its way out. A quantum computer, on the other hand, using superposition, can go down many paths, if not all at the same time, and find that exit much, much faster. Now, that next term is called entanglement. This is that second principle, which describes a unique bond between particles. When qubits become entangled, the state of one will instantaneously correlate with its partner, regardless of the distance that separates them. It's like 2 synchronized clocks. When one time is altered, the other, no matter how far away, reflects that change instantaneously, right? This phenomenon underpins the essence of quantum entanglement and is pivotal for that collaborative problem-solving prowess of what quantum computers really are.